So in this set of notes, we're looking at our category of exponents, which includes square roots, which in this situation we're going to be looking at our square root of -1, which are known as imaginary numbers, and the process of simplifying them. So it is impossible to take the square root of a negative number, as no number multiplied to its exact self equals a negative number. So even if we took -2 times -2, that's the definition of squaring, is you have to multiply it to its exact self. You can't be changing up the sign. Then you get a +4. And obviously a +2 times a +2 would still give you a +4. So you can't do it. So thus it is an imaginary concept, which mathematicians just simplify down to I. So if you are given something that says, for like number 1, the square root of -4, what you're going to want to do is write the number as being multiplied by -1. So basically composed of its factors, 4 and -1. So separate out that -1 from the rest of the number. Then you can actually, remember, break any radical into 2 separate roots. And then you're going to square root them individually. The square root of 4 in this situation is 2. And in this situation we have the square root of -1, which we just rewrite as I. And boom, we're done. Okay. So if we have this example, we have a -8. We're going to do the exact same process as number 2. We're going to make sure we separate out that -1. But then we look at our 8 and go, you know what? We can actually simplify our 8. So we're going to break the factors down even further. We're going to write as the factors with at least one of them, in this situation, being a perfect square. Obviously, if this is a cube root, then you want to be able to make sure that it can be a number that's perfect cube, and et cetera, et cetera. So factors of 8, 4, and 2 has 4 being my perfect square. I can separate them into individual roots. I can then take the root of each one, and the square root of -1, I just write as an I. I rearrange and I'm done. So what if we end up with something that looks like this as a problem? Okay. We are going to use the exact same steps up here from 2 through 6, basically, in my numerator. So 2 through 6, same exact steps. To go take my square root of -8 and to simplify it down to 2i times the square root of 2. Now here's where it gets a little tricky. And if you saw one of my other videos regarding operations with roots, you cannot divide the square root of 2 by 2 and turn this into the square root of 1, because the square root of 2 doesn't equal 2. It is just a more complex, or actually simplified in this situation, version of writing what the square root of 2 is, which is 1.41421 blah 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 blah, which is not divisible by 2 in the sense of being able to simplify it down to equal 1 and cancel out. You just get more of a divisible decimal, excuse me. So You do not divide by 2. You do not divide the root by 2. It's off limits. It's protected. But anything out here is fair game, because this is attached by multiplication, and this is a true 2. Okay? This is just writing the square root of 2 because you don't want to write out 1.41421. So then that means that only numbers outside of the radical sign can be divided by a whole number. Obviously, if there was a square root of 2, you can do it that way. And I can add that in here by a whole number. Okay, so we're going to just separate this guy out here and say, okay, well then these can separate and simplify, and I'm left with I square root 2. Okay, so take a moment and look back over that. This one's off limit, this one's available. Simplify, and what you're left with. Now if we're coming back here and we're starting off something like this, and this is what we end up with, instead of being divided by 2, we get divided by 6. You go, well, what do I do then? Again, the square root 2 is still off limits, but this 2 isn't. So we're going to rewrite it as a fraction, and we're going to simplify it down to 1/3. And that is what we then get. And then it ends up being all over 3. Over here, I did include some perfect squares. So that way when you are simplifying out the square root of -1 and you're looking for a factor that is a perfect square, then these are some of the factors. And so you'd basically just do, okay, well, 72 divided by 4, is that the largest perfect square that goes into it? What about divided by 9? You know, et cetera, et cetera, et cetera. What about by 36? Oh, look, hey, look, that goes in. There's my perfect square that goes into it. All right, so I hope this helped.